Hi. Okay, so we have covered VHDL data types, we covered VHDL operators, we talked about VHDL signals and constant. Now, this is the most important concept of VHDL programming. This is process block. So, by now, we have learned that VHDL executes its statement concurrently or parallelly in the architecture body. But we also said that VHDL allows you to write your code in sequential mode whenever you need to execute your statements sequentially. So, how this segregation will happen? How VHDL compiler will know that what statements should execute concurrently and what statements should execute sequentially? Well, this has been decided by the VHDL process block. Anything which you write inside the process block will execute sequentially. So the VHDL compiler knows that, okay, so this is written inside the process block, so execute them sequentially, and the other statements which are written outside the process block, then execute them concurrently. Simple. Okay, so let's quickly see some of the important informations first about the VHDL process block. So as I said, VHDL process block executes the statements sequentially. Next, the process blocks are being written inside the architecture body. You can write as many process blocks as you need it for your projects. There is no limitation to that. But make a note of that all the process blocks will execute concurrently. Don't be confused here because although the statements inside the process block will execute sequentially, but all the process blocks inside the architecture body will execute concurrently. So follow the signal assignment guidelines in those such requirements. Do not worry, we will be talking about that later in the series. Next most important item is the sensitivity list in the process block. This is the key part of your process block. If you miss it to write a proper sensitivity list, then your program will not behave as same as you are expecting from it. We will be discussing that in some time as well. Note that this process block concept is one of the most important thing in your VHDL and FPGA designing journey because this is going to be widely used in your VHDL and FPGA designs. So do not skip this. Well, let's talk about its syntax. Let me read this first and then we will decode this. So it is process name, colon, process, sensitivity list in the bracket, then there is some declarative section, then begin, then the body section, and process, semicolon. Let's decode this now. So the first line, process name, colon, process, sensitivity list. So this indicates the start of the process block with the name and a sensitivity list. The sensitivity list includes signals that trigger the process when they change. We will talk about this in some time. Process name is optional here, but as a best practice or a good practice habit, always try to specify the name of your process. This will be helpful when your program will have multiple process blocks. So if you give them some name, it will be easy to identify them in future that what process is written for what function. Anyway, then we have the section between this process start line and the begin statement. Here you can make any declaration for your process block, like you can declare any variable here as per your needs. Note that whatever the variable you are declaring here in this section, that will be available for this process block only. These declarations will not work outside from this process block. So make a note of that. Next statement is begin. So this is the indicator that you are starting writing your sequential statements from here. Write any sequential statement, whatever is needed in this section now. So once you are done with your statements, you need to close the process block or end your process block. So the last statement is end process name. So this is the end of your process block. Now some quick notes for you in the bottom section about the sensitivity list. So sensitivity list is a list of signals which are going to be used within the process block. Process block will only run when any signal from this sensitivity list changes its state. We will be discussing this in more details in some time. But before that, let's quickly see some of the examples. So this is our example one. I will read it first. So task 1, colon, process sig1 begin, sig2 gets a value of sig1 semicolon and process semicolon. Let's decode this. So this process block name is task1. Sig1 is written in the sensitivity list, then begin statement, and we retain our statements that sig2 gets the value of sig1 semicolon, and in the last and process semicolon. Now, because we added sig1 in the sensitivity list, so this means that this statement sig2 gets the value of sig1 will execute every time when sig1 state will change. Means whenever sig1 value will change, this process block will run. Means this statement will execute and sig2 will get the value of sig1. So this is very strict. Now let's see the another example when you are using two signals inside the process block. Okay, so we have this example of simple AND gate function. So I have written tasks2 colon process sig underscore A, sig underscore B, begin sig C gets a value of sig A and sig B semicolon and process semicolon. So the process name is tasks2. And in the sensitivity list, we have sig A and sig B. Both of these signals are using inside the process block for doing the AND gate operation. So we written begin and started writing our simple statement. Sig C gets the value of sig A and sig B semicolon, and in the last AND process. Now let's talk about the sensitivity list first, and then in the next slide we will see that what will happen if you forget to write any signal in the sensitivity list and why it is important to write sensitivity list carefully. So the sensitivity list is simply a list of signals that act as an input to a process. The process block does not execute continuously. Instead, it waits for one of the signal in its sensitivity list to change their state. And when a signal in the sensitivity list changes, the process block starts to execute. And once all the statements within the process blocks are executed, the process block stops and waits again for any signal in the sensitivity list to change its state. So the key points are number one, triggered execution. So the process block executes only when there is a change in any signal listed in the sensitivity list. Number two, sequential execution. When the process block triggered, then all the statements within the process blocks will execute sequentially. Number three is simulation behavior. So during the simulation, in case of multiple process blocks, all the process blocks will execute once at timestamp 0. Means at the very start of the simulation, regardless of the sensitivity list. If a process block has an empty sensitivity list, then it will continuously execute in a loop, and this may cause the simulator to hang or crash. So do not leave the sensitivity list blank in any case. So this means that the sensitivity list is a crucial component of a process block in VHDL, and that need to be determined very carefully in your VHDL designs. So coming back to the example, now I hope that you can understand this very easily. So this process block will run whenever the value of sig A or sig B will change, and you will get the output, which is the AND operation of these two input sets. It is very straightforward. Now let's see that what will happen if you forget to add sig B in the sensitivity list of the same example. I have just explained you this, that what the sensitivity lists do. So give a guess that what would be the output when you don't list sig B in this example. Okay, so let's reveal this now. So here at the bottom, I'm showing you two waveforms outputs. Note that our process block here, so we did not list it sig B in the sensitivity list, but we are using sig B signal for the AND gate operation. This means that when your sig A will change, then only your process block will run and your statements will execute. But when the sig B will change, your process block will not run, and hence your statement will not execute as well. And because nothing is executing, so there would be no change in the output. And you see this in the waveforms at the bottom. See the first waveform when sig A changes. So the simulation starts when both sig A and sig B are 1, and hence the output of 6A is also 1. And when A changes to 0, the output signal C also changes to 0 because this is AND gate. So this is expected behavior, means AND gate is working fine. But now come to the second waveform. Here again, the simulation starts when sig A and sig B both have value 1. Hence the output at 6A is also 1. So this is okay till here. But then the signal B changes to 0. Hence, as an AND gate operation, we should see the output signal 0. But look at this waveform. We did not get the output 0 here. Even there is no changes in the output. Why? Because when signal B changes, then this process block did not run and the statement also did not run. And hence there is no changes in the signal C output. So it is continue as its last value. And this is wrong because we are expecting the output 0 here as an AND gate operation. Okay, so we learned about the sensitivity list in the VHDL process block, its role and how it controls the execution of the process. We also looked at an example to see the sensitivity list working in practice. We learned that why the sensitivity list is one of the most important part in writing the efficient and correct VHDL processes. So it is important to ensure that the sensitivity list is not empty. If a process block has no signal in its sensitivity list, then it will execute continuously, which can cause the simulation to hang. Always include at least one signal in the sensitivity list to avoid this issue. Always add all the signals inside the sensitivity list which are input to the process block. This must be added in your good practice habits. There is an exception to this rule, which we will discuss when we cover the suspensions in VHDL. So that's it for today. In the next session, we will be talking about registered process. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.